The buzz is in the air. All right. So I'm very pleased to introduce Jim Gibeaut as our speaker today. Jim is the Endowed Chair for Coastal and Marine Geospatial Science at the Harte Research Institute for the Gulf of Mexico Studies at the Texas A&M Corpus Christi University. Jim got his Bachelor of Science at Ohio State University in 1983. He went on to get a Master's of Science in Coastal Geology at the University of Rhode Island in 1986. And then his PhD in marine science at the University of South Florida in 1991, which makes us pretty close to contemporaries there. Jim's research focuses on coastal change. He has worked in a variety of locations worldwide, but lately has focused his efforts closer to home and is contributing in a major way to the Texas Coastal Resiliency Master Plan, which he'll talk about today. So, Jim.
Thank you, John, and thanks everybody for coming out and for everyone tuning in. And thank you very much for the invite up here. I really appreciate it. It's been a little nostalgic. I think it will continue to be, but also just some amazing things that have changed as well. So it's been, I've been in Corpus Christi for 16 years now. And I don't make it back here as often as I would like sometimes. So let me get this started here. So, yeah, the Texas Coastal Resiliency Master Plan has been one of those overarching things that we've ended up doing in my group at the Harte Research Institute, which is an institute within the Texas A&M Corpus Christi, very interdisciplinary institute, Marine Science Institute. And that is really important for being able to work on a project like this, because it takes so many different people to do it, and with those that have different interests and different backgrounds as well. And so it's a very important program, a project for the state of Texas. It's the leading coastal management plan for Texas. And we've been working on it since actually 2012 in my group, way back when, but it has grown and has been added to and has become much more sophisticated in the recent years. It's this data-driven process, which is a very important aspect, which it's a stakeholder-driven process, which is a critically important aspect of this. And it's a little different from doing your research and your science within a program like that is to bring in all stakeholders, but it's very important in order to be successful. First, resilience. Okay, it seems like, or at least this is what I say for, well, what do you do in my lab? Well, we map coastal environments, we look at past change and then get the best maps that we can of today, and then make model projections of the future about what the coast is going to look like, where the beaches will erode, the marshes turn to open water, and things like that. That's in general what we do, but it's all done in a framework of improving coastal resiliency in Texas. And that is the new phrase, which is very important to include in all your proposals and your goals of what you're going to accomplish in talking about resiliency. So there's a number of different definitions of coastal resiliency or resilience, and I picked the shortest one for this, just to get it through there. The ability to absorb disturbance while maintaining functions and structures. And so in a coastal setting, this means being able to live with sea level rise and to recover from those hurricanes or ongoing erosion that may be occurring in your particular area. And resilience is often divided up into, a natural resilience of the natural environments, and also the human environments, the communities along the coast. And so in a nutshell, That's what we call resilience. There are more technical definitions of resilience, but really it's just one of those phrases that has started to become the new in phrase to use. Oh, it has been for a while, but it means a lot of different things to different people. So the threats to the ecological and community resiliency on the Texas coast, we have storms, we have the hurricanes, we have sea level rise. And one of the fastest one of the coasts with the greatest amount of sea level rise ongoing and projected to continue into the future. And this has big impacts because it's such a low lying and gently sloping coast. Small changes in rise make big shifts in the dynamics of the coastal plain. And also the land is mostly subsiding as well, which just enhances the amount of impact the sea level rise has. We have overall eroding shorelines, and we hence have a lot of habitat loss. So critical habitat for our economy, for tourism, as well as fisheries, and also for protection, our own protection. Marshes and flats and beaches and dunes help protect communities from, and other environments behind them from storm surge, for example. So this is so important here in Texas. 25% of Texas population is in the 18 coastal counties, and that population is expected to grow dramatically in the future, by 50% even. The Resiliency Master Plan is run by the General Land Office. It's their program, but all the agencies are involved essentially. That have activities in the coast. And I need to mention Joshua Oyer. He's the coastal planner and TCRMP coordinator for the GLO, and Tony Williams, his boss, is also greatly involved, as are a lot of other people at the GLO. One of the big advances or turning up the heat on the coastal plan came from hiring an engineering firm, actually funding in a significant way AECOM to help track all the projects and all the evaluations for us. And then Holloway Environmental Communications, very important, the communications of the plan. So lots of graphics and document preparation by them, and help in running the meetings. And then of course the Harte Research Institute, as I mentioned, we got it started in a much smaller way back in 2012. And what the plan does, it's an overview, it's a vision to protect coastal communities, infrastructure, and ecological assets from hazards. It's also an adaptable plan. So it changes as conditions change. From past years, we're in the third iteration of the modern plan now, and it will always be changing. And it also should be able to plan for future changes with regard to sea level rise, as a baseline shift. And then the 2023 plan follows on earlier 2017, 2019 plans. And the overall goals and objectives of the plan is really to identify and determine top tier projects. So basically it's a group of projects, but it's a bit more than that. But in the end, that's what everybody's looking for. What did your pet project get on the tier 1 list of the TCRMP? And these projects, are supposed to address coastal vulnerabilities and restoration, enhance, and protect the Texas coast. So we have a method where we think that we can pull out the best projects. And then communicate the environmental and economic value and vulnerability of the Texas coast to the rest of the state and the national audience. Here's an overall framework. It's adapted from a DIPSR diagram where you have drivers, on the left there, economic, social, natural. You have pressures. Those drivers create pressures. They can be natural processes or human activities. One example is sea level rise as a pressure on the coast, and then storm intensity and community and industry development. And then there's a list of vulnerabilities, and these vulnerabilities are very important because we ask the Technical Advisory Committee to assess how important each of these vulnerabilities are by Harte watershed, modified Harte watersheds. And so you can see them there. And then we also bring in a lot of data analysis plus the TAC input. And we also provide the TAC with information and data for them to make their expert opinions. And then we have the state of the coast in the 3 different principal realms: society, ecology, and economy. Develop actions, what we should do, manage the coast, manage the wetland environments, things like that. And then strategies, and they can be ecological, societal, or administrative. And strategies refer to the type of work that you're doing, like beach nourishment or marsh restoration. Then administrative policy can be part of the recommended changes made by this TCRMP. And then, like I mentioned, in the end, it's a group of individual projects that translate our goals into actions that potentially could happen on the ground. One thing the TCRMP is not is a funding program. You get your project on the tier 1, and then the funding has to be pulled together from other means. But it's very important to get your project in the tier 1 category. Speaking of the Technical Advisory Committee, we did a co-production process here, or stakeholder driven. Co-production is a very important term now with NOAA. Now I have another NOAA project where we had to, in the proposal, actually talk about what our co-production process is going to be and who are the groups of people that you'll bring together to help guide the project. And that's exactly what co-production is not just to give you feedback or opinions or be a sounding board, but actually a group of people that will collaborate with you to let you know what really needs, maybe even guide the direction of the project. So that's what the TAC is for this. It's our co-production partner in this. So it's a group of over 100 people that are knowledgeable about the coastal issues, not just anybody. So it's a curated list of people. And they come from a variety of areas: government, academia, NGOs, consultants, industry, and representatives, some elected representatives. And they often have backgrounds in science, usually have backgrounds in science, engineering, socioeconomics, policy, or planning. And their role is to provide overall advice as we develop the plan, as I mentioned. And then they assess those vulnerabilities in the previous slide, those vulnerabilities that we have by Harte watershed, and tell us what they think are the principal issues are. That's what they do initially. Then they'll review the actions, the overall actions that we propose to do, and then they'll start identifying potential projects, and they will actually submit potential projects to the project to advance, hopefully, the key problems in those watersheds. And they will also review and score projects, and then it goes round and round. So the vulnerabilities assessment, here on the right are the areas, the sub areas, the Harte watersheds, essentially, in which each of these vulnerabilities were assessed by the TAC members. It's a lot of work to go through as a TAC member and do them all. So that's not required, of course. We only want you doing assessing the vulnerabilities for the areas that you know about. And nonetheless, we had 82 different TAC member responses, not 82 for every sub area, but spread across the sub area. And the colors here are the numbers of responses that we got per area, per sub area. And so they scored these vulnerabilities: Gulf shoreline change, lost habitat, storm surge, bay shoreline change, water quality, inland flooding, tidal flooding, and water quantity, distinct from water quality. Here are the general results of the latest assessment that was done for the 2023 plan. And you see in Region 1, and I forgot to mention, but where do I have that? I'm sorry. Region 1 is the upper coast, includes the Galveston Bay area. Region 2, Matagorda Bay area. Region 3, Corpus Christi Bay. And then Region 4 is the South Coast. And so Region 1, the top three concerns from this was storm surge, Gulf shoreline change, and inland flooding. And then we go down to Region 2, this is the Matagorda Bay area. They weren't so much concerned of storm surge or Gulf shoreline change relative to Region 1 anyway, but they were really concerned about lost habitat, loss of the habitat within the bays mostly. Then Region 3, Corpus Christi area, the coastal bend. Gulf shoreline change oddly came back as a concern. It's a matter of trends and what's been happening most recently lately, and because the Gulf Coast has a pretty good supply. The Gulf shoreline is retreating, but not nearly as critically as, say, the upper coast or South Padre Island. But there had been some issues, and so it did pop up on the central in the coastal bend here. A lost habitat again, and bay shoreline change. Region 4, Gulf shoreline change, lots of development right up next to the Gulf, and degraded or lost habitat, and water quality is a key issue, top three issue down there in Region 4. So how the TAC project assessment goes. Okay, so they did the vulnerability assessment for us. And as I said, we provided them with information and all, and they filled the gaps in with their own expertise. There's a few different reasons to have a TAC, to have a co-production process. And that's one of them. We don't have perfect data. We have gaps. And so we're asking people who know what's going on to fill in those gaps. So they did that. That's one reason. Another reason for the TAC, really important, is that you need to bring people along with this whole process. They need to be part of it. They need to have ownership in order so that when you get at the end, you don't have a lot of people just putting it down what you just went through, because it's everybody that worked on it. So anyway, when we get to the project assessment, now the TAC will help compile projects, and we compile a lot of projects for assessment. AECOM is one of the big parts of the plan that they deal with. And then the individual TAC members score each project. And they score it based on three things. One, how well the individual project addresses the 8 vulnerabilities. And it's this Likert scale, 0 to 4. The feasibility of actually doing the project might be great, but it's a dream, forget it. Priority for improving resiliency. Is it a priority project? And so the TAC members do this scoring in 5 different in-person meetings for the 2023 plan. We've done it virtually before also. And people were able to talk about the projects and to exchange information about the projects And then the TAC members would score either there, or they'd go back and score and turn their scores in for each of these projects. In 2019, they reviewed 250 projects. 123 ended up being listed on the tier 1. And they totaled, if you were to build them all out, $5.4 billion. So far, there's been some progress there from the 2019 plan. Projects completed 7 for $20.8 million, and projects fully funded but incomplete 32 of them for $303.7 million. The 2023 plan reviewed an additional 215 projects. 121 projects were listed in tier 1, with 50 of those carried over from 2019. And here's a summary of the 2023 projects and a little bit about the types of projects they are. And this is in dollars, and you can see the number of projects within each of those bands. But I don't know about you, but I have a little trouble with these colors, so I had to write these down. You got 1, 2, 3, 4 principal project types, and they include beach nourishment, shoreline stabilization work, and that could be on the Goff or on the bay side, mostly on the bay side, and habitat creation and land acquisition. Land acquisition, that must be that one down here. Land acquisition projects, by the way, typically score very high in meeting all the vulnerabilities, and the TAC scores those projects quite high. But you can see there's a variety of different projects there. It would cost $1.87 billion to build that out. Now, let me show you some of the information that we provide through the TCRMP, and also gives us for the public to give us an idea of what we're facing on the Texas coast. Why would we spend $2 billion or more on these projects? So a major part of what we do at HRI for the plan is this modeling of sea level rise and storm surge. And as I mentioned, historically, sea level has been rising along the Texas coast. These are in centimeters per year. And so 5.6 centimeters per 100 years. So 5.6 millimeters per year, for example, 6.5, 4.3, 5.6, 3.8. Fairly high rates of relative sea level rise along the Texas coast. And the storm return period. Major hurricanes out here, the storm return period starting up here is 26 years. So the upper coast is a bit more prone to hurricanes than, say, Region 2, Matagorda Bay area, the 52-year return period. And Corpus Christi is just sitting great with a 105-year major hurricane return period. And then down here, 52 years. And so there is some variance along here. And I'll just tell you that the central coast, the coastal band is like one of the most resilient areas, is the most resilient region in Texas. I don't just say that because I live there, but there are choices that people could make if they knew. So the modeling framework, we start out here with a sea level affecting marshes model, a SLAM model. This is our sea level rise model, our landscape change model caused by sea level rise. And it's not our model, it's an open source model and was developed by others. And here we have sea level rise scenarios that we put into this model. We have a 0.5 meter sea level rise scenario, which is an intermediate low. I'll talk a little bit more about that later. And then an intermediate high scenario of 1.5 meters. So we're bracketing, what's likely on either, or the likeliest middle part of the sea level rise projections, I would say. So we run the model, and we create a 2100 land cover to 2100. So we see how the marshes have shifted according to the model, tidal flats, shorelines, and also the surface, the elevation surface. And we fill that in with some additional information that the model is not good at, or doesn't provide at all. And that is information on land cover that's above that is upland areas. And so we use CCAP data, which is a NOAA Landsat product, and we fill in the non-wetland land cover types, to the output that we got from the sea level rise model. And then what we really want to know about storm surge is, yeah, it's important to know where you're going to be impacted today in today's situation with storm surge, but you also, to really get the true effect of sea level rise, you need to model those storms on top of a surface that's been modified by sea level rise to see what the future impact of storm surges will be. And so for that, we use an AdCirc model. We run it here on Stampede, here at the TAC. And it's coupled with a wave model, SWAN, called SWAN. And here we run it for storm surge purposes. We have synthetic storms that we run. We choose, and for this project, we've run 19 storm scenarios, both on the present day surface and then the surface that's been altered by sea level rise in 2100 for the low sea level rise scenario, and then another one for the higher sea level rise scenario. And then we also, inputting this and preparing that surface to run a realistic 2100, or realistically as we can get 2100 hurricane, we also add some more information. Again, USGS land use land cover change modeling for the upland areas, how they've changed to 2100. We also add that in here. And so we run present day 2100 for the low and the high scenarios, and then we'll run with project scenarios and without. That actually hasn't been working out so well. We're going to have to do another approach on that. So we get surface elevations from these 19 synthetic storms. And then HAZUS is a model that FEMA developed to look at how certain natural events like hurricanes will damage the infrastructure that you have, the human built environment, number of buildings damaged, number of people displaced, and things like that. And so we run that also to illustrate that real socioeconomic impact. And then we have what we call these geohazards and vulnerability maps that we generate from both this sea level rise modeling and the storm surge modeling. And we take a look at that, and this is a nice map that integrates all these data and gives people a good view of what their vulnerabilities may be. A very important part is the digital elevation model. So this is key. All this would not be possible to be done very well anyway without LiDAR technology and good LiDAR surveys. And so we put a lot of time into developing the optimum LiDAR surveys using other people's surveys, including the Bureau's surveys in places and the USGS. And what TNRIS has gone out and gotten. We've gridded these data to a 2-meter resolution, and that's what all the modeling is done on, 2-meter resolution. It's a seamless DEM for the entire coast, and you can download this by the DEM through our data repository GridC, which I would love to talk about, but don't worry, I won't. Sea level rise scenarios, those low and high scenarios come from the NOAA report. And this is the 2017, they came out with a 2022 report, but we were already invested in this one, and the 2022 didn't change much anyway. And so we have 4 planning regions, as I mentioned, and we're using 2 global mean sea level rise scenarios, 1.5 and 1.5. And so there's a few percent chance that, well, there's a 98% chance or so that the actual sea level rise will be greater than 0.5 meters by 2100, and a very small chance that it would be greater than 1.5 though. And so we're bracketing the most likely situation here. And then we have a total of 57 storms that we run. We have 19 storms, but we run them under 3 different conditions: present, and 2100 after low sea level rise, 2100 after high sea level rise. And they're all Cat 1 through 3 storms. We didn't model on purpose any Cat 4, Cat 5 storms. And that's because we wanted people to, we wanted the most likely thing that people could grasp, that they may have experienced themselves already. And so we thought Cat 1 through 3 would be good both for planning and also impress the public. And so these are the curves here. Each of the 4 areas have their own land subsidence rates as well. So we're actually, the relative sea level rise is actually greater by 30 or 40 centimeters than what we actually have here when we show the global mean sea level rise. Texas coastal environments that we're really looking at, the wetlands, they mitigate flood damage. Coastal environments, they occupy a very small elevation range, a very small tidal range. And so just small increments in sea level can have broad shifts of marshes turning to open water, or flats going to seagrass, and things like that. So Texas is very sensitive, and these coastal environments are very sensitive to sea level rise. The environments can transition landward if they're given enough sediment, if they have enough sediment in time to do that. And so the rate of sea level rise can be important. And also the space needs to be kept open to allow for upland migration, or we'll get this coastal squeeze effect and we'll lose environments, net loss of environments. Just to show you one example of that is we have a lost fresh wetlands here. And this is actually running the intermediate scenario, 1 meter global mean sea level rise that we did for 2017. And we also use it here because it's in the middle. But you can see lost freshwater wetlands in this color up here, and lost salt and brackish wetlands. Lots of loss on the upper coast, less so down here in the coastal bend. But what do we gain? We gain actually salt and brackish wetlands also with that 1 meter global mean sea level rise. And you can see the yellow areas are where these marshes have been able to migrate upward in the model. But they're only going to be able to do that if something doesn't get in their way, like a freeway or a housing development, things like that. You can see also a lot of open water is being gained on the upper coast and on down here. But that idea about we'll lose a lot more salt and brackish marshes if we don't pay attention and allow the corridors of migration. And in fact, 30% of the new marsh in 2100 actually develops on undeveloped dry land today. Undeveloped dry land today is the place where 30% of this new marsh is actually created under the low scenario, and under the high sea level rise scenario, 64%. So that's very important. Here is a landscape change, adding a few more different units here: developed dry land, undeveloped dry land, freshwater wetlands, salt and brackish, beaches, and open water. And this is a little complicated looking, but the color codes are, region 1, 2, 3, and 4 for each unit. And then this color, the first one, is the entire Texas coast. So we have a net loss of developed dry land over here, looking at the low sea level rise scenario, undeveloped land as well. Freshwater wetlands, we lose a lot, but we actually have a net gain of salt and brackish wetlands. But again, these are being developed on that undeveloped dry land that could become developed. And then beaches and flats, it's kind of flip-flops there. Then open water, we lose in all areas, environments to open water environments. And then the high sea level rise scenario, we have, everything's just exaggerated really for the most part. And we still have generally the same patterns and same relationships among the different regions. And then open water, here we're more than 60% gain in open water in region 4, which is the Laguna Madre, South Padre Island area. And economic loss now. Let's take a look at economic loss and also the impact that sea level rise has on future storm surges. So here, this color is the present day envelope of water. This is the penetration of a Category 2 hurricane that lands right here in this region. This is Galveston Bay here. And so even today, we have, as we've seen, a big potential to flood big swaths of the coastal plain up here on the upper coast anyway. And then this little darker color is the additional area that will be covered in 2100 after the low sea level rise scenario. So you can see that right along there, right along up here. And then the darkest color extends that surge penetration even further. That's what we have with the high scenario in this area. So overall, we have an additional 309 square miles that are inundated with the intermediate low sea level rise scenario for a Category 2 storm. And that's over what is normally, that is what will be inundated in today's situation without sea level rise. And then with the intermediate high scenario, 634 square miles. So this is a huge difference, actually, especially when you think about, well, there's lots more activity, human activity going on, the higher you get here in some cases. And so we run Jesus with these three different situations, Category 2 with a present, intermediate low, and intermediate high sea level rise scenarios. And it provides output for things that we've chosen here, building loss. So let's just take a look at building loss. Present day, this is how many buildings we would lose. This is that doesn't seem right. Well, we'll go back, but anyway, you can see that it's almost 5 times more loss of buildings with a low scenario, and then even greater, twice as much again of building loss there with the high scenario. And then there's other number things here, content loss, relocation, things like that. But let's go back and look at the total here. You can see 234% more damage than today's storm, if it were to occur in 2100, and 492% in the future. Now, this is not adding any more economic development. This is what would happen, because we only use one database for input for all the buildings and their uses and the people and all, and that's the latest census data. So we're not advancing any census data. We're not projecting it. We're just holding still. And so this is if there's no more economic development that occurs. This is how much we would get. And of course, there will be more economic development unless we change things around a bit. And so these numbers would be even higher here by 2100. And then we go down to Matagorda. You can see here the scale is much shorter here. It's 0.8 billion. So this is all less than a billion down here. You can see though huge amounts of areas with storm surge, and big areas increase in storm surge after sea level rise. But the changes reflect that, the percent changes reflect that, but the overall damage is less because there's much less development here. And then for region 3, Corpus Christi Bay, again, not that much, a bit more damage than the earlier, and then the region 2, Matagorda Bay, because there is more economic development down here, more people, but we don't have too much of a wild increase over here on the total losses for region 3. Again, it's reflecting the physiography of this area. And then last one here, South Padre Island. We see these big increases again for the higher sea levels, and this follows suit with the other areas. A lot more of penetration in here with the storm surge compared to the region above it, region 3. So now let me switch to a map we call geohazards map that we integrate this information. And it's kind of a 4-dimensional map, so to speak. Let me go over the geohazards units first, and then I'll show you the maps. It's a relative vulnerability, of course, and low we call our upland areas that are not expected to become future critical environments. The critical environment are marshes, beaches, dunes, flats, things that are really important to the ecology, but also are buffers to human activities. And so low is those areas that are going to stay upland areas, and they don't have a very high storm surge vulnerability, less than 0.5 on a scale of 0 to 1. And then moderate, these are upland areas. They're also not expected to become future critical environments, and but they will become flooded as sea level rises, and on a frequency of more than 0.5. And the high geohazard areas are areas that we do expect to become future critical environments by 2100. And so these are upland areas today. They don't have any special protection or anything like that, but they won't be upland areas. They'll become these intertidal critical environments or near tidal critical environments by 2100. Then future flooding, some of those places just won't turn to a different environment because there's urban areas or roads. So those we put as blue. And then imminent, these are present day critical environments. So those critical environments that are out there today that do have some protections, wetlands, dunes, and beaches, for example. Then extreme are storm washover channels we map from historical occurrences, and future open areas. So marshes and all are flats that turn to open water. And so here's the overall coast. And we can see, let me look over here first. So this is the low sea level rise scenario. This is the high sea level rise scenario. You can see again, up on the upper coast, there's a lot of yellow up here, places that are turning to critical environments. There's also urban or industrial areas that are flooded. You come down here, we have a lot on the backside of West Bay there going on, environments turning to critical environments. And then on around here, the west side of Matagorda Bay is really a hot spot for coastal change. And that's where one of our signature state parks is now, right? And we come down here and it's a lot greener, right? It's the coastal bend. There's not so much going on there. And then down here, again, all those wind tidal flats are projected to turn to open water, and hence I get the extreme label there. Over here, 62% are low, the safe upland environments. 6% are low, are moderate, and then 5% and all around here. And then here, it doesn't change a whole lot. Is 60% is still in the low category, upland category. And we do see, though, that here we have a smaller number here and a larger number here. That's because these environments are turning to open water. So they're going from a imminent to an extreme category. Real quick, the geohazards map, region 1. You can really zoom in on these. The scale again is at 2 meters resolution. And you can see that this region 1 does not have very much of the pie in the low geohazard category. Region 2 is a bit better, but still lots of areas prone to change over here and around Matagorda Bay. And then Corpus Christi Bay, there's just not much going on. There's this area over here where there's a lot of change, and hence it gets the yellow, the high rating. Back on the side here, in the barrier islands as well, they're not in such great shape. And you can see, though, that the pie here is very big for that low category. It's gets a little less here, but still compared to the other regions, it's in good shape. And map, the region 4 map. These wind tidal flats, they're projected to turn to open water. Of course, we have a lot of uncertainty in the modeling. One of them is what is the proper sea level rise scenario. But apart from that, let's say we got that right. What's the sedimentation rate? We do input vertical sedimentation rates that's available in the literature, or that in our case that we have taken in the Corpus Christi Bay area. But still, these are just points here and there, and it's a really complicated intertidal zone in Texas. It's not like the broad monotypic areas like in Georgia or something. So in summary, and this is my last slide, I would just like to point out a few things. That again, the wetlands will be lost due to relative sea level rise. And that will decrease our resiliency because they're an important natural buffer. They provide a protective ecosystem service to us as well as to our economy. So in losing those wetlands, we'll lose some resiliency and we'll be more vulnerable, both natural and built environments. And in this century, and with no mitigating action taken, communities will become more vulnerable. So if we just continue on the way we've been doing, we'll continue to have more and more issues. More rainy day flooding, more sunny day flooding problems, for example. And even minor hurricanes, because of relative sea level rise and land cover changes will allow further impact by storm surge. Then the ecosystem conservation restoration projects and from the TCRMP, they're coupled with development or responsible development are critical components for increasing overall resiliency. So we have to have different policy also and different planning. And then this is an adaptable plan and using co-protection process, which I'll say again is very important in order to not just get clobbered and have everything you did be set aside at the end. Geohazards maps, we think we're going to work more with those, and there's a lot more data visualization and analysis to do here with the results. But I think the geohazards maps is a particularly good product for this, getting a feel for what's going on. And so with that, I'll stop here, Ron. Thank you.
Thank you, Jim. Wait till we get the microphone beach ball thing. You probably haven't seen this before.
No.
It's tossable. Go ahead, Chris.
That's right. Thanks, Mark. Jim, that's a very interesting talk. Thank you. With the Coastal Resiliency Master Plan, it seems like it's really focused on individual projects to address specific issues that are happening in different parts of the coastline. We got to rebuild the beach here. We got to restore this habitat. When these discussions are going on, especially with stakeholders about how can we do this, is there any aspect of this discussion that focuses on prevention? Like, can we not build in this area or stop pumping fluids out of the ground or other things that might influence the causes of coastal change instead of just the effects?
Yeah, there is discussion about that. And I think we'll see that in the next version. It's been a gradual process. We have a lot more of, beware of these issues. And here are some of the things in the plan, some of the things that are being done about these or, initiatives that the GLO is taking. But I think in the next plan, I think that's a natural evolution to break out of just individual projects and start working on overall policy development and products, more actionable information to do that. In fact, we're working on one of those proposals right now.
Oh, cool.
Yeah.
Look forward to chatting about it.
Yeah, I should tell you also all the data, they're not available yet on Grid C, but they will be this summer. They'll be ready for everyone. Yeah.
Hey, Jeff.
All right. Well, Jim, nice talk. It's good to hear you speaking again. Since the last time you were
all
here.
along, by the way. Go ahead.
So just in general, it seems like when we use models to predict future change, we chronically overpredict things, and no worse than in the coastal realm. So with that in mind, what's your gut feeling about, you look at the upper coast, for example, you see huge areas that are inundated by water. And do you really think that's going to happen?
Well, I think it's possible. Yeah, I don't know. I'm not gonna put my finger on that. This is what is going to happen, but I think there's a good likelihood that it will, good probability. But I get your point, and I often sit back and look at some of these maps and I think, I can't imagine that. It just can't happen. But, you know, sometimes you have to navigate, you know, and use your radar. You just
Yeah.
have to trust your tools.
Yeah, and like on the Texas coast in particular, when we look at, you know, a series of aerial photographs, it seems like almost, 90% of the change occurs during storms and episodic events, and and then the whole time between them tends to be recovery. And so, it's actually hard to imagine that much change occurring. But I'm not that these aren't good exercises to go through, and it may be accurate, but is there any hindcasting that you're thinking about doing that would, look at data we've had in the past and see how this process how accurate it might have been and the change we've seen already?
Yeah. That's a hard thing to do, but it's worth trying, even if it's imperfect. Going back far enough in time is difficult when things haven't been changing as much with regard to sea level rise anyway. We do see these trends that are caused by, arguably by sea level rise, with high flats turning to marshes over time, for example. And so I think there are examples of that we can see this process happening. And of course, what really hits home is the sunny day flooding, or the tidal flooding. So there's more times you can't pass along that road, for example, and that's become very evident to a lot of people. But I agree, and that's one reason why we go with a range of sea level rise scenarios, so that we have our bases covered, and it still gives us a good planning tool. When I first started this work on Galveston Island, I wouldn't even accelerate sea level. I would just use a linear rate based on historical rate at Pier 21, and that was because I didn't want to get into the argument with whether or not there's really global warming and sea level is really rising. All I was asking people to do was look at what we've measured in the past, and there's some examples there where you can see the impact of that rise, and just project into the future that same rate, that same process, and it's obvious we need to start doing something differently.
Hey, Michaela.
Hi, thank you for your talk. I'm really curious about the tier process and why some projects have been completed, why some haven't, and if any of those 100+ projects end up getting funded eventually. Yeah, just curious about why things weren't completed versus things that were.
Well, it's because of the funding, and some projects were lined up with funding from say Restore, for example, the Restoration Act, stemming from the Deepwater Horizon oil spill. Others, have champions in the NERDA process, natural resource damage assessment. They get funds from that. Others, with our own CEPRA, the state of Texas, the Coastal Erosion Planning Response Act. So it's just, they happen to hit the funding cycle right and and meet the goals of that particular funding entity is all that's about. But it's still, if you don't have it on tier 1, your chances of getting funding are less. And this is what people think. And this is what everybody's telling us. 6 years ago, nobody was paying attention except for the TAC. Now, the city councils, county governments, they all want to know what's going on and whether or not they're getting tier 1 projects, even though it doesn't mean any funding, from the TCRMP process. Doesn't mean any funding. It's not a funding program, but they know it will help them with their other sources.
Thank you.
We've got a couple of online questions. Catherine, would you like to ask yours?
Yeah, thank you very much. This is Catherine Romanak from the Gulf Coast Carbon Center. And I'm really interested in your outreach. I think it's brilliant and it's important. And we are going to the Gulf Coast to do outreach because of CCS projects coming into the area. And we did a survey where we found two different types of people along the Gulf Coast. The types that have what we call high science orientation, where they're people that enjoy science shows, they look for science media, and they digest science easily. And then there's another group of people that don't digest science very easily. They are a low science orientation, and they would rather just listen to their community members. They don't care to try to figure out the science, but if Joe down the road thinks it's good, then they think it's good too. So what I am really interested in is how did you vet the TAC? How did you go out and find members for the TAC? And how did you decide on who would be admitted onto the TAC?
Yeah, okay, I'm not gonna, well, I'll tell you what happened anyway, more or less. We started out with a list of people who, and this was back in 2012, actually, when we started to grow the list. Back then it was the active consultants, it was NGOs, very key. And then federal natural environment managers, very important too. And so just the usual, group of people that we knew it was their career to understand what was going on along the coast from whatever point of view they're bringing. And so it started out just like that. We just know who's active, who's on those staffs. And so then we started to expand and add more people in planning, I would say, and decision-making roles local along the coast. And that's kind of where we are now. So really, I mean, we weren't going for just a general interested public person. So if we couldn't find you, then maybe you probably didn't belong on the TAC anyway, right? Okay, so really that's what we do. And so how do we decide? That's really up to the GLO. And the GLO, with advice from the team, from AECOM and from HRI, we'll take advice and we'll just discuss it, whether or not this person belongs on the TAC, what they could offer, or are they just, one thing we try to avoid is just single interest people who are just interested in getting their projects through the process. So that's about all I can tell you.
Okay, thank you.
Sure.
All right, we have one more question online and then we'll cut it off there.
Jenny, would you like to ask your question online?
Yeah, sure. Hi. I'm just interested in what you see as the important process studies that remain, or what important data sets are needed for you to make big gains on improving your future projections.
That's easy. Subsidence. We need a lot better, more detailed land subsidence data for the sea level rise modeling. We have pretty good data in the Galveston Bay region, the subsidence district up there, and we did put together our own subsidence surface for use. But when you get away from there, there's not much. So I look forward to being able to see a lot more land subsidence data. That would be the one thing. I have to think about the second one because that one is so prominent.
All right, well, let's thank Jim again.
Thank you.